Hello. Hello, everybody. Hi. So, my name is Paul Evans. I'm Solution Area Expert at Net Insight. And here today I'm going to talk about enhancing facility security with the focus on the SMPTE recommended practice RP 2129. So, for years, broadcasters and operators have been using have been using SDI and ASI as final handoff or outputs. But with the migration of this traffic to IP-based networks and infrastructure, we're using newer SMPTE standardized IP protocols such as the SMPTE 2022 and 2110. Now, operators and designers are encountering additional security and routing challenges that we must overcome. This year? Okay, so we'll start by just looking at why broadcast technology is migrating to IP networks. So, first of all, cost efficiencies, right? We're all come from broadcast that's been around for a long time, and dedicated hardware is very expensive to produce. It takes a long time to produce it as well. So, utilizing standard IT infrastructure is really a cost benefit. And from a flexibility, scalability point of view, it's going to allow us to adapt the way we process our signals with the changing demands of our customers. We can improve production by using IP-based workflows. So whether this is cloud-based or if it's remote production, we've got support for essentially high bandwidth signals with low latency. And finally, like the last two things is that standardization is huge in IP. Every part of the chain in IP is standardized, from the SFPs all the way through to the signals that run over the top of the networks. Everything in layer 1, 2, and 3 and above. And finally, future-proofing. We don't know what the future holds, but as long as we've got bandwidth, we've got a chance of achieving future needs. So SMPTE RP 2129 is a recommended practice. It's not actually a standard. So what's the difference here? Well, it is what it sounds like. It's going to be a recommended practice. And I split this into two variants. There is the part that is specific to your vendor. So you want to use a vendor. They're going to have to follow part of this. And then as an engineer or a designer that's going to build the network, you then need to follow the sort of recommended practice of how to implement those. So you just Google it. You can find these two documents. There's two documents with the QR codes on there. So trust boundary fundamentals. So this is kind of the main concept of trust boundaries is essentially that we're creating a trusted and an untrusted network, and we're basically joining them together. And that's where obviously the problems come in. And, security is a big thing that comes from IT. So we have to adapt this. Now, there's firewalling rules that we need to look at, which I'll show you in the following slide. But these are the sort of fundamentals that the trust boundary is implementing. So the most important thing that we look at, first of all, is the IP media firewall. So now this is not to be confused with a traditional security firewall because it's not the same. It's not got the same feature set. So this is specific to media and specific to broadcasting and probably exchanging networks. So we have to understand that this is not like a Cisco or a Palo Alto or something like that. So here you can see on the left-hand side, we've got the service, we've got Ethernet, we've got IP, RTP headers, and our media payload. And in the middle, we've got our media firewall. So I'm just going to talk you through how this works just so you get an idea. The first thing you do is you configure your IP media firewall to accept the flow. So we open up the port in that firewall with a multicast address, port, source address, RTP payload type, that type of thing. Once that's been opened, you then allow the service in, and we start to monitor the service. We look at the RTP headers, look for the RTP sequence numbers, but also PTP is also in there as well. So we strip off Ether and IP headers, and we maintain that RTP in the media payload. We then configure our output, pass it through, and we rebuild it based off the media firewall interface. So that's kind of how it works, and you can see that we're maintaining the bits that we really need. Now, why this is important is we're seeing a big uptake in Net Insight on 2022-7. So this redundancy mechanism works really well when you start to capture this with the IP media firewalls. So here's my source, right? This can be anything, but I like the analogy that we use this as a remote production. So this could be a camera with a 2110 source. So we generate a blue and a red feed, pass it through the media firewalls, configure it. We maintain the RTP headers and the media payload, rebuild it, pass it through, and finally, we do the merge at the end. So it's important that we're merging it at the very end. We're able to pass it through devices, which means we don't have to merge it at the bit when it enters your facility. And so what this means is that you're not masking any issues because you're not healing anything in the network. Okay, so again, we're still talking from the vendor's perspective of how these parts work, but we've got the toolkit. Now, the toolkit this is the bit that's going to make your lives a bit easier when you're using them. So we've got address translation and port translation, and then monitoring. We've got RTP sequence numbers, as well as, I think that's IAT and PDV. So this gives you a bit of information about jitter and path delay variation if you are doing some 2022-7. Rate limiting. So the rate limiting is probably one of the most important features of the whole box, because I think most people have probably come across a situation where you've put a signal into a system that's slightly larger than it should have been. Someone's put a 3 gig STI signal as opposed to a 1.5. Maybe you put an extra 0 on the end of an encoder and it's 200 meg instead of 20. Well, the rate limiting is there to prevent that. And the most important thing about rate limiting is that you do it at ingress. So whenever that hits you, that's where you want to do your rate limiting, because that's going to protect the rest of your network. So replication of flows in the trust boundary is also a really nice feature, which I think is underused heavily. But you can use this device essentially to replicate the flows and pass one through to your final output or your production. But also what we can do is we can send one through another interface to your monitoring network. So it kind of works the same concept that you're using multicast, but it's more from the device, and it's more from a GUI, so it gives you it's a little bit easier to use. So you can think of this as almost like using a traditional distribution amplifier or something like that. And finally, some support for protection, which is we've talked about the dash set. All right, so that's kind of like high level. If you what I think about RP2129, and next I want to talk about some use cases. So these are a couple of use cases that are based off some customer opportunities that we're using. So this one, I can't actually tell you the customer, but they are based in Germany, a very large broadcaster. And so this slide's a bit difficult to follow, but I'll try and talk you through it. You can see in the blue box, we've got a customer facility. And inside that customer facility, we've got data center services, cloud production, asset management, these type of things, as well as studios, playout, distribution, and also remote production. So it's a big facility, and it's a big 2110 facility that uses MMOS. So then in the middle, we've got the trust boundaries. So as you can see, this connects down into this facility at 600 gig. So this is starting to look like something you'd find from Cisco or something, because the bandwidth is so high. And obviously we're dealing with 3 gig signals. You're going to quickly eat that up. On the right-hand side, we've got all these different types of connections coming in. So think of these as my untrusted parts. So my trusted is going into my facility. My untrusted is on the right-hand side. Different service providers, different broadcasters connectivity, as well as facility trucks and even regional studios. These are all things that can be considered as untrusted networks. So I don't think you can be able to see there very well, but you can see there's some blue boxes just above the trust boundary, and this is where all the bits that we just talked about come in. So as the services come through from the service providers, we're going to do some rate monitoring, so we can make sure that they are what they are. They meet their SLAs that we've agreed with them. We're going to use, obviously, the media firewall to pass those through, so we can make sure that the service provider's network is not directly connected to our facility. And also what's really interesting here is where service provider 2 there is handing off JPEG XS flows, we're actually decoding them as well. So we're decoding from JPEG XS into 2110 and handing that off as 2110 with NMOS to the facility. So it's a bit of a different mindset. And when you take away the network part of having both ends, and actually we look at it and going, actually, I want to protect this facility and I want to do it in a safe way. And that's kind of what has happened here. We're seeing a lot of people interested in this, especially broadcasters or anybody with big, chunky and large services, large quantities and big uncompressed services. Okay, so we'll do a remote production use case. So this is Matchday. Matchday is a remote production company based in Denmark, and DMC is the name of the production company, and they teamed up with the Danish Football League to create a company called Matchday Productions. And Matchday Productions is very modern. They actually only formed a few years ago, and they went live last year for the first time with this project. But they're extremely lean and have really modern concepts of how they want to do remote production. So they do everything at like a bit of an 80-20 rule. So first of all, they've got 10 facility trucks, and each one of those has the media trust boundary, has Nimbra trust boundary in there. So these trucks are capable of doing 2110 inputs, but are also capable of doing SDI. So depending on what they get at the various different stadiums. So the trust boundary there is essentially protecting any traffic that's in the truck. It could be audio, it could be EVS, anything like that. It's protecting from it's entering the IP network. So we're taking those sources, we're encoding them into JPEG XS, carry them across that IP network, and only those flows passing through. And then we get to the broadcast center. So on the right-hand side, then we've got now another trust boundary, which is essentially segmenting these networks. And network segmentation is one of the most important parts when you read through the RP2129. We've got the trucks here, we've got the network, and then we've got the broadcast center. Nothing can traverse across any of these unless we say so. No, if we configure it, I should say. Now, interestingly, you'll see down the bottom there, you can see an Oslo production center as well. So, and this is where this 80-20 rule comes in. So it's very small writing, but down at the bottom, you'll see how many football games that they do. When I say football, I mean soccer, sorry. They do like 192 games, for the League One, and then there's 192 for League Two. But there's only 2 days of the year where they actually, do all the games at one time. It's the first day and the last day of the season. Every other time, it's always like a mixture of times. So 80% of the time, they only need a certain amount of resources. So the main broadcast facility actually only accommodates for 80%, and they burst into the Oslo production center when they need for those only 2 days a year. They also use it for some VAR, so video assisted referee. So if they don't have any Danish referees, they can use the Norwegian referees. So it's quite a clever way of doing it. Now, the thing that's interesting about this is our devices also carry data services as well. We're capable, and we're able to segregate those. So we're able to segregate them at layer 2, so with logical VLANs and stuff like that. And one of the things that they like about this setup is they can use that as as an additional revenue stream. And that's kind of one of the big things why they chose Net Insight to do this project. Okay, so I'm gonna wrap up by just talking about a few best practices for securing your facilities. Most important piece of advice I can give you, and by the way, I didn't tell you, but I used to be a designer for broadcast networks in the UK, for service providers. So most important tip I can give you is security by design. Whenever you're doing your design, make sure to include it from the very start. If you do that, your life will be easier. If you have to retrospectively do it, it's a lot harder. And use RP2129. Okay, if you read through it, it's not that long, but it's very interesting and it's got some great points. I actually used this to talk to my cybersecurity team because I have to have my network design signed off by IT security. And when I said to them, I'm following SMPTE RP2129 as my as a best practice, and this is what my design was based on, they were a lot happier about it, and it was much easier to get that through and signed off. So we talked about network segmentation. This is obviously very important and a key part of IT. But essentially, we want to make sure that we're creating these network segments, these domains, the truck, the network, the remote production part. So make sure to design these segmentations parts in. Keep your trusted networks trusted and have your untrusted not connected. It's also important, I'm not sure if I touched on it earlier, to make sure that you use different physical interface for your trusted and untrusted networks. So just in case I'd missed that. So I would say modeling bandwidth is something that I would generally spend quite a bit of time doing, because it's very important that, especially when you're designing a network, to understand what your bandwidth is going to be. But more importantly, consider the future requirements as well as redundancy, because these are the type of things that, you build the best network in the world, and we all know broadcast is so dynamic that all of a sudden I've got an extra 10 services I need to have. So consider bandwidth modeling and future, based off future projects, things like that. Monitoring. So when we talk about monitoring, we talk about like service monitoring. Well, I actually think that infrastructure monitoring can be as important. But if you put both of those together, you'll get a much better monitoring system. So for example, I might know that a service is dropping packets, but my monitoring on my actual infrastructure is the one that will tell me where I'm dropping packets. Have I lost an interface? Is my light level low? That type of stuff. Is a link running at 95% capacity? These things will point you to the problems, and often before they come up. So that's a really good thing to let the monitoring do the heavy lifting. And then finally, some standard IT stuff, regular audits. Like I said, we in broadcast is so fast and dynamic. We're always adding services. We're bolting them on. We're bolting more in. Always, everybody wants more. So if you don't audit your networks, then you're never really gonna, then there's possibilities for security vulnerabilities to come up. And finally, employee education. I'm sure many of you enjoy doing your mandatory IT training, so it's important. But you say it, but the things that are important here is like changing passwords. I can tell you that we've actually checked some boxes online, and people are still running default passwords and things on boxes that are facing the internet. So change a default password, use a single sign-on, use Radius, LDAP, something like that. Those are very important things. So that's all I've got to talk about today. Hopefully you found it interesting. I'm at the Net Insight booth, which is down the end here. You can't miss it. It's covered in neon lights and American football and basketball. It's great. And yeah, I'll take any questions if anybody's got any. No? Good. I answer everything? Anyway, like I said, if you want to talk further or you want to see some more use cases, then please come down and talk to us. Thank you very much.